Good morning, everybody. I hope you can hear me. Good morning and welcome to the second session of the user forum on seamless climate predictions. We come together today to continue exchanging ideas or learning from one another, as we already started during the first session that took place on 24th of March as a part of the Climate Europe Innovation Festival. My name is Yaram Iziak, and I am Research Director at the Euro-Mediterranean Center on Climate Change, and I will be moderating this second session of the forum. Few housekeeping rules at the beginning. Please keep your microphone muted when you are not speaking. Then we are recording this session. That means if you don't want to appear on the recording, please keep your video camera closed. The speakers will be invited to open their video camera and their microphone when invited to the floor. Excellent. Thank you very much. You might post any question to the chat or the question answer tool. I think we have enabled that, Andrea, right? And you might comment as we go. Right. I will first introduce the reason why we are here and the project that is hosting this user forum for those that have not attended the first session. And then I will explain the scope of this second session, as well as the structure that we have chosen for this. So Aspect is a Horizon Europe project that is focused on developing extended climate forecasts that go beyond the typical 5 till 10 years range. In order to make them useful, we will downscale our prediction to the user relevant scales, including for extreme weather events up to 30 years into the future. Our goal is to offer a seamless and user-focused method and data to help people plan and adapt to climate change impacts. We recognize that the people who will benefit from our work understand their specific challenges and application best. That's why we are collaborating closely with you to ensure that our research meets your needs. Aspect will bring together various types of climate information to create a user-friendly delivery system that builds upon ECMWF experience with climate change services, as well as the climate data store. Our team is dedicated to making a difference in climate research, and we believe that our work will provide valuable insight that will inform the planning of adaptation in your places, in your region and cities. Now, this is the second session. The first session that I mentioned was organized on March 24th. It was attended by around 140 attendees, including scientists, social scientists, users and providers of climate services. They have discussed the reason for using climate forecast, as well as the enablers and barriers they face. They mention enablers, including standardizations, improved standardization of the climate forecast, better visualization, better training, accessibility of the data, transparency, and funding. Among the barriers, we encountered a lack of funding, uncertainty that is embedded in the climate forecast, low confidence in climate forecast, as well as terminology that is not widely used or understood by those that might benefit from climate information. But the attendees also confirmed their interest in forecast at 10 to 30 years and multi-annual forecast for making strategic decisions. However, they also noted that there was a limited peer-reviewed literature on this topic, and they called upon more evidence to help to understand how to best incorporate the climate forecast into policy and decision-making. So this is the short summary of the first session. Now, in the second session, we will continue our discussion. Rather than continuing in a broad forum with many people from different sectors, we try to keep the second session more smaller and more focused on the technical aspect and the user relevant information, as well as the way how to deliver that information in order to make the difference. So this is why the number of attendees for the second session is relatively low. and it's limited to those that are interested to work with us, explore the data set that we will be developing in this project, and becoming also super users. Super users, we will explain what it means, but just to recall, we are offering opportunity to get embedded and work closely with the scientists in this project in order to convey what kind of format, what kind of information you might best use for your policy and decision making. That will give you an access to experimental forecast, including downscaled forecast to your regional domain that might be tested in your operational environment. Right. But I will keep it because there are other people more knowledgeable and better informed about how this will work. They will introduce this topic by themselves. So just wrapping up this introductory section, thank you very much for being with us. Your participation in this forum is essential for us and for the success of this project. And I encourage all of us to take advantage of this forum to share our ideas, insight, and questions. As we gather here, let us also remember that we come from different backgrounds, but we share the common interest in improved climate risk and information needed for this end. So we hope to engage in productive dialogues and build connection that will last beyond this meeting and eventually might include your participation in this project. So this is it for the beginning. I would like at this stage to invite the first panelist to join me on the floor. And we have picked up high level, very experienced and highly distinguished researchers from across the different work packages of the project to share their views, how the information that we are developing looks like and what kind of systems are behind. So I am pleased to invite Madalena Balmaceda, who is the head of Earth System Predictability Research Department, Earth System Predictability session. She's an expert on predictability, initialized seamless predictions, and ocean-coupled reanalysis. Then we have Panos Athanasiadis, who is a senior scientist in the Euro-Mediterranean Center for Climate Change, holding a PhD in meteorology from University of Reading. He's an expert on prediction and extratropical climate dynamics. And our third panelist is Bina Saroyini, who is a climate scientist at the University of Oxford Physics Department. And she's an expert of seamless climate prediction and coupled forecasting. So with those three panelists that are covering different work packages and different bits of work that we are developing, we have invited them first to share the initial statement with all participants. And you have the opportunity to ask them the question after the initial intervention. So without any further ado, I would like to pass the floor to our panelist, and starting with Madalena from ECMWF.
Hello, thank you for the kind introduction. And good morning, everybody. It's my pleasure to be here and to introduce briefly, very briefly, the plans that we have in Aspect Work Package 1 regarding the new integrations that we are planning. So I don't know whether I need to share my screen or...
We can see the screen already.
Okay, that's not mine, but maybe it's next
no,
slide.
Yes, that's correct.
Yeah, thank you. So it's going to be brief. This production of climate integration is we have been doing this for several years, but we noticed that there are some deficiencies. One of the deficiencies is that the design of the seasonal and decadal and projections is quite unconnected. So we try to sit together at the same table and try to optimize this production, especially for taking into account more seamless production for user application. So what we intend to do is first to improve the forecasting systems. It's not the work that we are going to do necessary in this work package, but since the last round of seasonal forecastings and decadal forecastings, the models and the capabilities of predictions have improved. So we want to include these new capabilities in the new generation forecasting system. Then the other deficiency that it is generally accepted is that to capture signals and extremes in these predictions, we really need to have large number of ensemble members. This means more data to analyze, but it's the only chance that we have to capture signals and to have confidence level. So we are proposing to increase the number of ensemble members, both in seasonal, decadal, and projection. Then, as you well know, to use this prediction seasonal and decadal, we need calibration and skill assessment. And for that, we need to run a large number of what we call reforecasts that are cases in the past. And we try to extend the number of those cases. So, for instance, for seasonal, we had only 93 to 2016. With the new generation, we could extend to 1981 to 2025, or even beyond if it's required. But we don't want to do everything at once, so we need your input regarding your needs, and some of the groups will try to explore enhance this reforecast period as much as possible. But what we agree is that bringing them from up to 2022, 2025, it could be very good. We have the recent cases in the data set. We also want to enhance the temporal frequency of the reforecast, probably to yearly. And the most important component of this work package is to produce what we call this bridge integration. So there are integrations that traditionally were not covered. So some integrations that bridge seasonal with decadal, and that's done by either extending the seasonal to 24 or 28 months, or enhancing the ensemble members of the decadal for these first 2 years. We believe that this is not only scientifically interesting, but also of great potential for application, especially in the view of this prolonged 3-year La Nina. It's not the same to have a drought that if we know that we have hopes that it's going to finish next year, or if we think that it's going to continue for the second year. So that's the motivation. And the other bridge integrations trying to connect more the decadal with the projection. And that can be done by extending the forecast range up to 20 or even 30 years. So because those are new and we want to explore them, perhaps the protocol is a little bit more loose, so different groups can explore different aspects. And we need your help for this exploration and assessment. So we have prepared a questionnaire, but it will be circulated to gather your feedback, your initial feedback on what you think is of interest for you. And we plan to do this, have an iterative process. So after the first year or 18 months, we can repeat it again to see where we are. That's all for me. If you have any questions later on, happy to answer. Thank you.
Thank you very much, Madalena, for this brilliant overview. I would first perhaps invite the second panelist to extend this presentation of what we are aiming here. And I give the floor to Panos. Panos, over to you.
Thank you, Yaro. Just to double check that you can see the slides here, because Magdalena, I didn't.
We see the slides, but not in full presentation mode.
Sure, but I was expecting Magdalena to move to tell me to switch the slides. I'm
Right.
sorry about this, Magdalena.
No problem.
So, okay, briefly, I'm Panos Athanasiadis from Euro-Mediterranean Center on Climate Change from Bologna, Italy. And I will briefly discuss some further aspects of climate predictions and their skill here. So to begin with, what types of climate forecasts we have available and we are going to develop in Aspect. I presume most of you are already familiar, but there's no harm to remind ourselves some basics. So seasonal predictions are produced. We have 12 forecasts issued per year, and each of these cover the following 6 months, as you see at the top. Typically, these are assessed using 3-month average anomalies. Then in the lower part, I show decadal predictions. Decadal predictions are produced once a year, and they cover the following 10 years. These are typically offered and assessed in terms of anomalies averaged over a number of years. So the new things that will come in Aspect, that as Magdalena was mentioning earlier, is on the top, what we call extended seasonal predictions or interannual predictions. This will be produced twice a year, so initialized in November and May, and will cover the following 2 years. So this comes to fill the gap between seasonal and decadal, and will meet also various needs expressed by end users. At the bottom, we also see another set of predictions that will come to fill the gap between decadal and long-term climate projections, extended decadal, let's call them. This will be initialized, will be produced every 5 years, and will cover the next 20 years. And to provide information at the 20-year range, which is particularly useful for adaptation. Here for reference, I have just listed some sources of information for data and real-time forecasts. These are all multimodal ensembles. And you see for seasonal, decadal predictions and climate projections, just for your reference. So going now to some aspects of seasonal predictions first. As we see on the left, here I present you correlation scale for precipitation at the bottom and near surface air temperature at the top. As you see, generally speaking, seasonal forecasts, the predictability and the skill are generally higher in the tropics, as you see also in these maps. This relates to the origin, to the sources of predictability. Second point is that the skill is significantly higher in the first month and then generally decreases along the forecast, which is a typical thing in all kinds of forecasts. The skill depends on the target calendar season, but also on the initialization month. So you may have higher skill for winter, for instance. And over Europe, there is more skill for air temperature and less skill for precipitation and wind. Just to say a few words also about decadal predictions. Here on the left, we see again skill for precipitation and temperature. In decadal predictions, skill is generally assessed averaging a number of forecast years. The first year alone has less skill in general, and a significant part of the skill comes from multi-decadal variability and trends. There is significant skill for temperature, while skill for precipitation is lower and patchy, as you see at the bottom panel. While the skill for wind is also low, so over Europe, especially in winter, a significant part of the skill stems from the North Atlantic oscillation. And I will finish with a few additional points. First, I would like to mention that predictive skill is evaluated in various ways. So I showed you correlation skill, but also we analyze skill in terms of probabilistic skill measures and deliver probabilistic forecasts. In any case, the usefulness of the forecast information is not directly proportional to the skill, which needs to be kept in mind for developing services. And then apart from delivering time average anomalies, predictions can also provide usable information on the changing statistics, for example, frequency and intensity of extreme events, such as heat waves, droughts, and this can be also be useful for developing services. In certain cases, particularly so regarding decadal predictions over Europe, better skill can be achieved via hybrid approaches, and by this I mean through combining dynamical predictions of large-scale variability patterns, such as the NAO, the North Atlantic Oscillation, together with statistical information derived from observations. And this has been tested in some applications. And finally, while there are numerous forecast opportunities to be explored by end users and the aspect scientists working together, there is not always available a sufficiently skillful forecast for the need in hand. So this is something that we have to admit. And at this point, I will stop and I will let Bina, I will invite Bina to continue.
Thank you very much, Panos. And indeed, Bina, if you could take the floor. In the meantime, Panos, we are receiving the first questions, and they are very interesting. Just have a look on them, and after Bina's intervention, we will start taking them. Thank you.
Thank you, Yaro and Panos. Good morning, everyone. My name is Bina Balan Sarojini. I'm a researcher at the University of Oxford. I am going to talk about how we create and evaluate seamless climate information across space and time in aspect. Next slide, please. So what do we mean by seamless climate information? As Magdalena and Panos explained, we plan to develop model output in the seamless manner from different prediction systems like seasonal and decadal, and we also have climate projections. These are free-running climate model experiments, whereas seasonal projections and decadal seasonal predictions and decadal predictions are initialized forecasts. So Aspect will deliver actionable and reliable seamless climate information, which ranges from global to regional and local scales for time ranges from seasons to decades in the future. This is a collaborative research undertaken at different European research centers and operational forecasting centers and universities. There are two parts in our work package of the project. The first one is to create and evaluate seamless climate information using temporal merging techniques to join the best forecast on seasonal to 1 to 5 year to 5 to 30 year timescales together and apply them to user-relevant adaptation decisions. And the second part will also provide seamless climate information in high spatial resolution, including information on extremes using downscaling methods. Next slide, please. So what do we mean by temporal merging techniques? So I want to briefly introduce two methods. These are conceptual ideas to combine climate projections and decadal predictions. So in stitching, we use a best forecast in a distribution sense of the decadal predictions for as long as possible, and then replace the forecast or predictions. We don't have for example, in Aspect, this is what we are trying to fill the gap, as Magdalena and Panos mentioned, to provide predictions, initialized predictions up to 30 years. So with the existing model output, what we do is we can use an intelligent stitching by replacing the timescale after 10 years simulations from the climate projections. And the second method is shadowing. This is a method to identify particular trajectories from the sample of all ensemble members of the climate projections, which are close to a certain target trajectory. The target trajectory can be observations or observed state of the past, or it could be available decadal predictions of the future. So in this method, future, we assume that the trajectories will keep shadowing the true state into the unknown future. Next slide, please. After talking about how we create temporal merging methods, how we use temporal merging methods to create a single time series of seamless climate info, the second part is how we deliver high spatial resolution climate info. These are using downscaling methods. There are two parts, statistical downscaling. The figure on the top right shows downscaled data using the ECMWF seasonal forecasting system CES5 in 1 degree horizontal spatial resolution, and the atmospheric reanalysis ERA 5 in 0.25 degree resolution, and the ERA 5 land reanalysis in 10 kilometer resolution. The second part would be to provide downscaling of seasonal to decadal predictions in high spatial resolution using analog methods or machine learning methods. The other type of downscaling is dynamical downscaling, where we try to extract information on extreme events. That is to develop a method to systematically downscale extreme events using a physical climate model. So the figure on the bottom right shows 2 villages in northern Sweden, where we have shown topography, wind vectors plotted over topography shaded. So these are 2 kilometer downscaled data. And we also plan to provide a library of past and future extremes for statistical analysis. And the type of extreme events really in aspect, what is novel is that we try to co-develop these events we choose to study and produce data of using by co-developing it with users' needs. Next slide, please. So in a nutshell, what we can provide is provision of existing scientific knowledge of seasonal to decadal to climate info for using existing model data. And there would be annual feedback about new climate information sources tailored for user needs, which we create from aspect. And the third point would be a provision of a framework or methodology for downscaling of future climate and extreme events in a kilometer scale spatial resolution. That's all from me for now. Thank you for your attention.
Thank you very much, Bina, and thank you very much for Madalena and Panos. So we have listened to a comprehensive overview about what we are planning to do in this project, what will be delivered. We are here today to discuss your requirements, discuss the ways how this information might enhance your decision and policy making or your existing services. So you are very welcome to raise your hand if you would like to take the floor. We can invite you to pose the question to our panelists directly. Otherwise, you can also post your question in the chat. And I have seen already that there's been a lot of interesting discussion going on. So perhaps, Madalena, can I ask you to wrap up the questions to which you have very efficiently answered already and share that with the whole group? Thank you.
Thank you. So Christopher Nankervis, if I can pronounce your name, you asked if this aspect includes the subseasonal prediction, the 42 days range, and the answer is no. We decided to limit the scope to seasonal to decade from seasonal onward. However, because there are going to be more ensemble members in seasonal and more frequently, you may be able to do some skill assessment, but that's what is integrated. At this subseasonal time scale. I didn't say before the number of ensemble members we are considering in the range of 80 to 100 for seasonal prediction. There was other question, and it was whether this data is going to be publicly available, and that's a very good question. So what we are trying is to, in this project as well, is to prepare them to move on the research to operation, to the Copernicus services, to make it more agile. So one of the work package of aspect is concerned precisely with archiving this new integration in an experimental data set that mimics the Copernicus services, the CTS services. So, and if they are ready, then one can switch very quickly and put them publicly available in an almost semi-operational sense. But in the initial phase of the project, because it's going to be quite complicated, not all the integrations are going to be at once, at the same time, etc., etc. The information is restricted to the aspect partner or to those users or scientists that express a special interest and they are happy to collaborate. So if you are not an aspect, but you are interested in accessing these integrations and give your assessment, provide your assessment to us in this user forum, please contact Jaroslav or Marta or Nube. And I think it would be very good to have your input.
Brilliant. Thank you very much, Magdalena. I'm looking at the audience. I don't see any hand. I see new participants coming in. Perhaps, Nube, we could keep an eye on people that are in the waiting room. This is brilliant. Thank you very much. Now, I would like to ask all the panelists 3 questions, and this is not additional to what you have said, but because this forum involves people from different backgrounds, and partly they might be familiar with the terminology that we are referring to, but partly not. So I'll apologize if I'm going to ask you to repeat what you already included in your slides, but it's good to have these very, very concentrated messages. So my first question would be, what is the difference in terms of the insight that we get, but also in terms of the conclusion and result that we get from the multi-annual or decadal forecast compared to the short-term climate projections? Can we summarize with a few words why the predictions are better, if they are better, and why that might matter to the users? The second question I would like you to summarize is what we know about the skills. The skills for the wider audience is basically how well the climate prediction systems are truly anticipating what we will see into the future. So what is the performance of the prediction? So could you summarize with few words what we know about the skills for Europe from seasonal to multi-annual or decadal forecast? And the third question would be, what is the benefit of the seamless integration system rather than having a different system for different climate forecast? So if you could really, with a simple word, summarize, because this project is investing in a seamless, right, from seasonal to up to 30 years predictions, why the system is better compared to a separate systems that focus only on the seasonal forecast or only on the decadal forecast without having the aim of covering the time period seamlessly. I hope those questions are clear. If you, or any of you, if you could take whatever part of those questions you would like to start, and perhaps I start with Bina.
Thank you, Jaro. I would like to choose the third question, which I already introduced to the audience. So the advantage of using seamless climate predictions, as Magdalena introduced in her first talk, having different prediction systems would mean that the information is spread out is not available as a single source of information. That is, I'm saying from a user's perspective, a usability point of view. But scientifically, different prediction systems, when we say seamless forecasting system or seamless prediction system, it would use the same forecast model. This would mean that we are dealing with the information produced from the same source. And the second point would be, in forecaster's term, it would be a multi-model approach, ensemble approach. So we consider different European forecast models and produced a single ensemble. This would mean availability of more ensemble. That means we represent uncertainty better. And the third important point would be when we say seamless climate prediction, these are initialized climate predictions compared to climate projections, IPCC type of climate projections. The main difference is in initialized climate predictions, we represent, it starts from realistic initial conditions, which means we try to represent a more realistic natural internal variability. So this is the main difference. I think I leave it to Magdalena and Panos, who are going to address the rest of the questions.
Thank you very much, Bina. Excellent, brilliant answers, Ella. Thank you. So Panos, shall we go back to you and then after to Magdalena?
Yes, thank you, Yaro. I don't know whether I should respond to a specific question or just give some answer to.
You pick up whatever you want to answer to.
Yeah, I will be happy to comment on all questions, but we can come back, I think, as in the second round. So just to make some first comments on your first question, you asked what are the, let's say, the added value of initialization of having decadal predictions that are initialized from a realistic state as opposed to climate projections that cover as well this near-term horizon of 10 years and beyond, but they are not initialized from a realistic state. In climate, there are components, we can call them low frequency components of multi-decadal, operating at multi-decadal time scale. For example, like the variability of the Atlantic meridional overturning circulation that needs to be initialized in order to the model to know the exact phase of this low frequency variability at the time of when you run the forecast, when you initialize the forecast. In projections, this is not the case. So climate projections may miss some of this information, and this is part of why decadal predictions can bring added value at this same time scale. We plan to extend this from 10 years up to 20 years. And as Magdalena mentioned in the comments, there is also another set. I didn't mention them earlier because they are not really, we will not assess them as predictions, but they are initialized climate projections. So Magdalena may say more on this if she likes. I would be happy to comment as well on the second question briefly, because you mentioned the interannual and multi-decadal time scale. So there have been already some attempts internationally, and there have been a couple of articles published on interannual predictions. So we have seen that there is skill beyond the first 6 months. So what we call seasonal predictions, there is skill beyond this horizon, and we really would like to harness this this predictability. But to do so, it is necessary to have a large ensemble, and the skill will practically to begin with, we will explore skill coming from ENSO, from El Niño Southern Oscillation that affects also Europe. And yeah, this is about the second question. I will stop here and let also Magdalena comment. We can come back to second round if necessary. Thank you.
Oh, brilliant. Thank you very much. And over to you, Magdalena.
Yeah, well, I think Panos and Dina have covered it quite well. Perhaps to add the importance of this So prediction is initialized. We need to know what is the state of the real world now, of the real climate. For that, we need observation. So it's going to be we are going to produce, if you want, these outlooks for the future, have into account what is happening just now. Well, the projections don't have that information. They only have the information of the changing greenhouse gases or radiative forcing. But for instance, they don't know whether we are now in El Niño or after 3 years La Niña, or on which phase of the decadal variability. So that's the traditional definition, which is quite important. But in addition to that, we are when these projections and predictions were set up as exercises probably more than 15 or 20 years ago, probably 20 years ago, we have not felt so much the impact of climate change. But now we are. So nature is on a state aware of a changing climate. And we need to know at which point of this change nature is. And the observations can help to constrain that. So if you have a projection, you don't know whether the projection has gone too far or too little. But with this initialized outlooks or decadal predictions or seasonal forecasts, we are constraining. We know what is happening now. So the probabilities should, in principle, be better because it's a conditional probability. However, having said that, the initialization process, the validation has its challenges. So even if it's the future, while we get there, until the technology and the science is able to get there, it's going to be a long path. And this is one stage, one step towards that direction. So that's a bit the difference between the predictions and the projections, and the new changing panorama that we have climate change now. Basically, that's what motivates this exercise. The other component, I don't know whether it has to do probably about a scale, this interannual variability and the sampling. So for decadal predictions, they are initialized once per year, for instance, or maybe they could be initialized twice a year. But we know that if we have El Niño, this can set up nature in a completely different track. So sometimes, so you have a decadal prediction in November. For whatever the reason, there is El Niño happening next year, and it was not initialized frequently enough because this El Niño can only be captured in May, for instance. So all the decadal predictions are set up in the wrong path. And that's why it is important to combine them with the other more frequent, even if they are shorter term, but more frequent predictions at seasonal or 2 years time scale, because we have the scope to correct later on. And there was another one, but I think seamless. Seamless is a funny word. It looks very good, but there is a lot involved in it. So, for at TCMWF, we say we have a seamless approach from days to season with the same model, but that model has different characteristics. It may be the same with the seasonal, the decadal, and the projection. The models may have different characteristics because you need to choose the horses for your coaches in terms of resolution, etc., etc. But what is important is the underlying methodology. And for instance, now the CO2 or radiative forcing that the seasonal forecast use may be different from the ones that the projections use or the predictions use, the decadal prediction. That's not right. Or the initial conditions are based on very different approximations. So we try to be methodologically consistent. So regardless of the uncertainty that is predictions entail, at least there are not structural basic flaws in the conception of the of the information.
Brilliant. Thank you very much, all three of you. So for the audience, in principle, the answer, the short answer is the seamless modeling is much better. The skills of climate predictions are improving, and they are getting interesting and closer to practical application. And in some cases, they might even be better implied than the projection. Thank you so much. There's one question that I would like you to quickly reflect, and this is from Ellen Theria, and she asked how a modeling framework will be dealing with shocks or drift in multi-decadal initialized predictions. So if you think you could answer this question quickly with less than 1 minute, please.
Yeah, well, Carrie, I think you know that there are two methodologies. One is, well, there is one methodology that is to do the bias correction a posteriori. We use the reforecast, and it's the lead time dependence bias correction. So with that, assuming that the bias is relatively stationary and the shock is stationary, you can get away with it. The other one that we are trying to explore in this 30 years initialized outlook is to drop the first 10 years and to look only at the difference between the climate in the, say, the 20 years center in the 50s with the 20 years center in the 20s, how the climate is changing. But Panos has this something.
Yeah, Panos, less than 1 minute.
Yeah, I can add in a few seconds what we have think about this. Eleftheria, it's a question that in fact has been raised within the project from the very beginning. It's a difficult point, if you like, but for the multi-decadal predictions, for those that will run up to 20 years, and I was mentioning earlier that will be initialized every 5 years from 1960 onwards, we have let's say a hindcast period that is about 60 years. So using these regularly spaced initialized predictions, we will attempt to remove at least the lead year dependent bias in the same way that we do with regular decadal predictions. So, of course, the drift dynamics remain, and this is the case also with decadal predictions. You cannot really go over this problem, but in the same sense that there is skill and ways to analyze decadal predictions in a similar approach, we hope we will be able to demonstrate that there is skill beyond the 10-year limit. Thank you.
Brilliant. Thank you so much. Fortunately, we don't have now time for taking more questions, but we will have in the second part of this session, we will have breakout groups, and please take your additional technical question to those breakout groups. Our three experts will stay with us, and they will answer, more than happy to answer them during the breakout groups. Now, without any further ado, I would like to invite Nube Reviriego from the Barcelona Supercomputing Center, who is the leader of climate services team at BSC. And she will introduce how we are going to work, what we promised to deliver, and what is the process of engaging after users. So this is the main reason why we are here, to discussing how this information might be useful for you. And Nube will explain the process of working with you as the potential super users. So Nube, over to you. Thank you very much.
Thank you very much, Yaro. Can you hear me well?
Yes, and we see your slides. Thank you.
Okay, that's great. Yeah, basically, as Yaro said, I would like to explain a little bit about the co-production that we are expect to do during the Aspect project with the super user. And also I would like to explain a little bit why it's so important to have you, the super user, here with us in order to tailor the climate information. So let me start with this infographic. in which you can see on the top a bunch of Lego blocks that are all mixed up. And this for me could be like a comparison of what is happening with the climate data that is out there. So there are plenty of climate data out there on the internet in different sources. But then this data that is here is not exactly the same that climate information. And basically, this is what we would like to tackle here in Aspect project. Through the co-production, we would like to really interact with the super user and understand the user need in order to being able to process all this data and tailor the data to the user needs. And then this is something, of course, that we are gonna do from the technical staff, and this is some of the methodologies that we are going to use has been already mentioned by my colleagues. But at the end, the idea is always tailor the climate information to the super user needs and being able to provide information that can be really useful for the decision making. So how we are planned to interact with the super user in Aspect. So basically, we usually make participatory approaches for this type of interaction with user. So basically, we are planning to have working meetings with the super user in which we can chat in a friendly atmosphere about what are your climatic needs and try to understand your context, because I think this is something that is really important. Try to understand your context, what worries you about climate, and what impact more to you. So all this, but also at some point maybe we can ask you questions, particular question by email, so a small survey, and you can just quickly reply to us. But also there is also the possibility to participate through the user fora, in which not only the super user can participate, but also some other user. Then through these participatory approaches, what we would like to gather is information regarding your climatic needs. This means here you can see the temporal scale in which the climate information can be. Here will be, well, I don't know if you can see my pointer, hopefully, but well, on the left-hand side. Okay, perfect. On the left-hand side, you can see the weather forecast, and then on the right-hand side, you can see the climate change projection. But in the middle, there is the climate prediction. So here in Aspect, as already said by my colleague, in Aspect, we are going to covering the temporal scale from seasonal prediction to decadal prediction up to climate change projection. So our idea is, through this conversation with the super user, we will be able to identify if you have climatic need in each of these temporal scales. Basically, after that process, we are going to be able to have a map of the super user decision that you can make having climate information at the different temporal scales. This is an example of agriculture. And for instance, on the left-hand side, you can see some decision that can be taken, having information with month or season in advance. In the middle, you can see decision that can be made using decadal information, and on the right, decision that can be made with climate projection. Basically, for instance, just one example, in the case of the agriculture, it could be possible to make decision on the harvest management, just having information with months in advance regarding maybe temperature, also rain, for the specific harvest month. But then there are some other decisions that are across temporal scales, for instance, water management. So in this case of agriculture, water management can be relevant, having information with months in advance, but also with years in advance, and also will be useful to have this information up to the mid of the century, for instance. So here in Aspect, we are looking for super users that are interested in dealing with decisions that go across temporal scales. I think this is important because then all these enhancements, that my colleagues has explained before can be used in order to provide you tailored information. Then, as soon as we have this map of decision, we are going to define the case studies. Okay. For instance, here I have bring you an example for you to understand what I mean by case study. So basically, a case study will focus in one decision making. For instance, in this case, following with the example of agriculture, our decision making will be water management, and then what we would like to co-develop with the super user is the specification of this case study for this specific decision. Basically, here we will be just co-developing with you what type of forecast we can use, if we would like to use seasonal or decadal prediction, or if, for instance, you are also interested in having information up to mid of the century. Then also we would like to understand what is the target period that is important for you. For instance, in this case, it's April to September, because this is the growing cycle of the wine sector, and they are interested of all this period. But this, of course, will be very dependent on the super user. Also, we will be discussing regarding the spatial resolution, because this is something really important. The way that we provide the climate information, it could be in 100 kilometers or it could be in 1 point. So, of course, this is also dependent on what you need, the super user need, and we will try to deal with that. And as well, the location. The location could be a region, could be a country, but also could be a very specific point. And then also the last part of the case study is also to co-develop with super user the different level of information that we can provide through the Aspect project. In that case, I would like to show you this infographic in which we have included the different levels of information. In the base, we can find climate variable. For instance, a super user can be interested just in temperature or in precipitation, whereas there could be other super users that they are more interested in having a climate indicator. When I say climate indicator, is like they can be interested in having information in advance about heat wave or cold wave, but also about droughts, for instance. Then there is one step further that will be the risk-informed hazard indicators, in which we, together with the super user, will try to combine different climate indicators in order to have an indicator that can inform about the risk that the super user can have. For instance, a heat-related risk or a sanitary risk. And then finally, in the top, we have the risk indices. And in this case, what we are expecting is that it could be that some of the super users have in-house tools in which they already make a decision based on this in-house tool, like decision-making platform or something like that. And they are interested in ingest into this in-house platform the climate information. So this is what we expect doing here. Maybe you are thinking, okay, all the super users need to cover the 4 levels of climate information. Of course not. This will depend on each of the super user and the case study that we could co-develop together. So this is open at this case, and we will co-develop together with the super user. And just let me finalize my presentation with this slide that is some of the benefit to become a super user that we see, but of course could be others a benefit. One of those is make better informed strategic decision for resilient to climate change and extreme weather. At the end, if you are able through the Aspect project to have climate information in advance, you will be able to make better informed decision. So this is, I think this is a great benefit. But also another benefit is that the super user or the user involved in Aspect could develop the understanding on extreme weather and climate risk, working directly with experts at both the Met Office and the Barcelona Supercomputing Center. So the super user will have the opportunity to interact with people like me and try to understand more in depth different aspects of climate risk. And this is also important. And then the last benefit that I include here is also that the super user will be one of the first co-producing useful and usable state-of-the-art seasonal to decadal prediction information. That, of course, this information will be tailored to the super user and will be benefiting you, but also will benefit many other organizations, because in somehow the super user will be like defining a little bit what type of climate information can be useful for society as a general. And I think this is all. Thank you very much for your attention, and open to question if you have some.
Thank you very much, Nubet. That was excellent. That was really brilliant. The participant got the overview about how they can benefit from this project, what they can take home, how they can contribute to making the result more tailor-made and impactful. We're a little bit in delay, so I would suggest that we keep the question for the breakout groups. But you were speaking about super users, and we have invited few of those potential candidates to become super users to briefly explain what they're doing and how they are using the different climate information, including the climate forecast. And the first, so all those will provide a short pitch presentation about the scope of applying those information. And the first pitch presentation will be given by Maurizio Mazzoleni, who is a team leader at the Institute for Environmental Studies at the Vrije University of Amsterdam. Maurizio, are you with us? Can you? Yes, yes, you can get prepared, and I can explain. Aspect is also one project that is committed to informing the mission adaptation to climate change. You might know this is the new part of the Horizon Europe project, where the research and innovation is closely designed and implemented with the administrations. And Maurizio will speak about one of the projects of the mission itself, which is called Climax. But Maurizio, over to you.
Yes. Hi. Can you see 1 second? No, wait, I have to switch. So now you see the screen, right? The full screen?
Yes, we do.
Yeah, great. Well, hi, good morning. And first of all, thanks for inviting me. As Jaro said, I'm Maurizio Mazzoleni. I'm assistant professor at Vrije Universiteit in Amsterdam. And together with Jeroen Aerts and Lena Reimann, we are leading the work package 2 of the Climax project. So today we give a really small introduction about the Climax project. What is the Climax project, what we are doing, and how we can see the synergy between Aspect and our project. So let's start first of all with the starting point. Why the Climax project? So let me move this. Everything started from the EU Green Deal. So the European Mission of Adaptation to Climate Change and also including the societal transformations. So the main objective of the Climax project is to focus on this mission adaptation and provide the tools and the knowledge to improve regional climate risk assessment and also emergency risk management plans. So the idea of the Climax project is to harmonizing and consolidating the climate risk assessment within Europe, and in particular to at least 50 communities and regions. And how we are doing this? So the project is divided in different work packages. And the first one, work package 1, led by CMCC, is focused on better understanding a different climate risk assessment procedure, while the second work package in which we are involved is devoted to the design of the toolbox. So the idea of the toolbox is to collect data about hazard, vulnerability, and exposure, and then to allow users to download also risk maps, climate risk maps, based on different type of hazard. It could be, for example, floods, droughts, heat waves. So the user could even upload their own map. And we are also thinking the idea of creating online risk mapping based on different risk assessment procedure. So we started with the design of the toolbox. And the idea of the toolbox has to be flexible, and it has to be used by different users. So they can also recreate their own climate risk assessment. So we will start from 5 different European pilots to identify the different risk assessment procedures they use, and then try to understand how we can design the toolbox in order that it can be flexible and usable by everyone. And of course, a part of the data that be included in the toolbox, we are also thinking to include guidelines, for example, how to do downscaling or uncertainty analysis, or the guidelines behind the different risk assessments. So they explain the users the rationale behind the different risk assessment. And the idea that we have of this toolbox could be something like this, that this is derived from the risk data app made by JRC. And the idea is that the user can click on the different tab and they can decide if they download directly the risk data or download the specific hazard, vulnerability, and exposure data. And this can be, for example, if we focus on the hazard data, can be different type of hazard, different type of data. It can be from historical observation or future projections. And this is where also the Aspect project could play a role, because we could also include, for example, climate projection or forecasting to see how this different information can be used in climate risk assessment, not only for the longer term projection, but also for the shorter or medium term, for example, seasonal forecast. And then the toolbox that we first designed together with only 5 pilot case will be also upscaled to at least 50 European regions. And the idea is that this project will empower this region with both the knowledge, but also the tool to develop their own climate risk assessment and becoming climate resilient by 2030. So the main output and objective of Climax is to provide this region and community with the climate risk assessment guidance for developing their own risk assessment. And this, of course, can be applied for any other regions. Thank you.
Thank you very much, Maurizio. So you got the idea. The Climax is basically the intermediary between Aspect project developing very interesting new novel climate forecast and predictions in the regions that will make a use of it. So the Climax project was setting the standards how the climate risk assessment at the local and regional levels should be conducted. Is the perfect amplifier for the impact of the Aspect project, and it might be the channel how to incorporate the information and exploit the synergies between two. Thank you so much, Maurizio.
Thank you.
Now, speaking about the regions, Now, Maurizio said we are going to serve different regions in Europe, but one of those regions that have signed the Charter of Mission Adaptation is Emilia-Romagna in Italy. And our next pitch presentation will be from the Regional Environment Agency in Emilia-Romagna, provided by Valentina Pavan. And she will explain the innovative use of climate information and the type of climate services that might benefit from climate forecast for practical applications. So Valentina, thank you very much for being with us, and over to you.
Hello everybody. I will present all the just a sec. Here I am. Didn't expect to talk now. Here I
Yeah, we just see the slides, not in the full presentation mode.
Yeah, I'll try to go for the presentation mode.
Yeah, perfect. Thank you.
Okay. So I'm going to present some products that we have developed within the Climate Observatory of Emilia-Romagna. Now, first, what is the Climate Observatory of Emilia-Romagna? In ARPA, it's a service which is meant to offer a description of observed climate, mean value, variability, forecast, and scenario product, included with the impacts on major some major aspect like health or agriculture over the Emilia-Romagna. So I will talk briefly about one of our product, which are about seasonal predictions. And later on, Rodica will present something about scenario products. All our products are produced including using both surface observation, crowdsourcing observation, satellite observation, all Copernicus products and ECMWF forecast combined together in order to produce some climate services, downscale predictions, and observation analysis, and to reach so our users and institutional and the local administration with reports, publications, but also forecast, climate services. And first, I will show you the seasonal prediction of irrigation water needed that we have set up for Emilia-Romagna. Seasonal prediction of irrigation water need have been developed within European project MOSES and Clara, and further developed later on in Islander. We combine information from satellite in order to produce an early crop map over Emilia-Romagna, use later on calibrated probabilistic seasonal focus obtained from the Copernicus platform, and produce seasonal prediction of irrigation water need. Later on in the season, we'll check and validate our prediction. Here I will show you the products that we have published in a paper of Metaps. These are
anomalies of water need that have been produced for the year from 2011 and 2020. In particular, you can see this is the mean value for Emilia-Romagna from the plain area of Emilia-Romagna. As you can see, the forecast most of the time are able to capture you see the years on the x-axis and the anomaly of irrigation water volume on the y-axis. The box plot represents extension of the extension of the forecast with the blue dots representing the median, while the red line represents the observations. And you can see that the forecast, the probabilistic forecasts are actually able to capture the sign and sometimes the amplitude of the forecast in most of the years, which is already a great result for seasonal forecast. Within the Highlander project, we also developed a similar procedure in order to produce a sub-seasonal forecast based on ECMWF monthly forecast calibrated with the collaboration of ECMWF and in order to assist our reclamation bureau and our regional users during the subsequent summer season. And I just stopped here and show you one more products that we have just developed. Here is a combination of observations observation from the thermal index for Emilia-Romagna. You see here the green line represents the variability over the last 30 years of the thermal index mean value of temperatures, 2-meter temperatures over Emilia-Romagna. The blue and the red lines, dashed line, represent the absolute minimum and maximum value over the since 1961, and the yellow interval that starts from the last point of observation, which is represented by the black line, is the 15-day forecast. I leave the floor to Rodica.
Thank you very much, Valentina. And Rodica, do you have anything else to add, please?
Yes, thank you very much, Valentina. If you are so kind to put again the presentation, to share the screen, because now I'd like to speak a little bit about our activity as concerned the future climate projections. This is the second activity that the climate, another activity that the Climate Observatory of the ARPAI are developing. Oh, sorry, Valentina. Just if you could share the presentation before, otherwise I will, sorry. Okay, oh, thanks, Valentina, yeah. So another kind of activity, as I said before, is those concerning the local climate projections. As a support to the regional government, local authority that has to construct their mitigation and adaptation strategy, or to construct the climate action plan or the local adaptation plan. These activities actually is developed also in the research projects such as ADA, that is a life project focused on the adaptation on agriculture. This is an ongoing project, or we are doing this in just a started project that is Transcend, is an Horizon Europe call. Valentina, if you are so kind to go ahead. So this kind of activity, we could do this because we are implemented more than 10 years ago. Valentina, just a slide before. Okay, we are implemented more than 10 years ago a statistical downscaling scheme that help us to construct future climate projections at a local scale. The statistical downscaling scheme is based on a perfect approach and is based on the link between local climate variability and large-scale atmospheric patterns. These large-scale atmospheric patterns are taken from the global climate models that run in different experiments in the CMIP5 or in the CMIP6 experiment, such as to construct future climate projections at local scale in the framework of different emission scenarios. We are looking on the local climate projection using different climate indices that cover temperature and precipitation, mean and extreme value. We are doing this, as I said before, as a support to regional government to construct their adaptation strategy and also to local authorities. How are our outputs, our products? Valentina, you are so kind to go ahead. So our products could be as a map of changes and also present and future. Something that's happened with the presentation because okay, so our products could be in terms of map, and also we provide to our end users the interpretation of this map. Here, just a small product that concerns the simulation of annual mean temperature over Bologna metropolitan area, so present 1961-1990, more close to the present period 1991-2080, and the future simulation through statistical downscaling scheme of annual temperature for the period 2021-2050 realized in the framework of RCP 4.5 emission scenarios. We use more GCM, such as to be able to characterize also the uncertainties. So our products are presented to the end users in terms of ensemble mean. On the right, for example, on the right side, I presented another product. Those are simulation of annual precipitation for the future. And also, for example, the simulation of heat wave duration for the Bologna metropolitan area. Another kind of products that we are provide to our end users, Valentina, please go ahead, is in terms of small summary, is an infographic that try to put together more information for more fields, for example, for temperature, for precipitation, present and future, for consecutive dry days, for heat wave duration, for tropical nights. So more indices that together could provide to our end users future climate profile. This future climate profile is then as input in the adaptation or action plan. We have done this in the Sustainable Energy and Climate Action Plan for our region. This was only two types of products that we provide to our end users, regional government for adaptation, but this kind of products actually we are constructed also in the framework of different projects that we are involved. Okay, thank you very much.
Thank you very much, Radhika. So that was an excellent presentation how innovative the public regional environmental agency might be in order to steer the development of adaptation at the regional and local level. Congratulations for your excellent work, and thank you very much.
Thank you.
Moving forward with the short pitches, I would like to invite Stefano Balli to talk about his perspective of a small SME that is working with public administrations and private users. And you might remember part of Jekos, his company, was also presented at the first session of the Aspect User Forum. So this is just a repeat and perhaps add some interesting detail. Stefan, over to you. You have 5 minutes.
Yeah, I'll try to stay in time. Thanks a lot, Yaro, for this opportunity. So my name is Stefano Bagli. I'm the CEO and founder of Ecosistema. In Ecosistema since 2001, we are providing environmental, geospatial, and climate risk intelligence to public and private customers. In the field of climate services and climate risk intelligence, we are combining geospatial data and climate data to get together with modeling tools and both data-driven, so more machine learning, and also deterministic models. So we have developed science more than 10 years, at least several climate services, and most of them has been developed in the framework of EU research project. So we started with Clara, and now we are involved in ICISC, that is a Horizon Europe climate research project focused on developing climate services. And yeah, we are also participating now in Talanoa and the Indirect project. I will try to just pitch some of our experience and climate services that has been developed in this framework. The first one is Safer Places. Safer Places is a cloud web application that has been developed together with, supported by EIT Climate Kit, together with the university and research centers. And the service provides climate risk intelligence at high resolution at urban scale. And one of the main components is related to the capability of the system to also simulate and provide future projection of flood risk in cities. So we are using Copernicus data, and we are very interested also to integrate, for example, decadal products that can give us also an added value to our service. And so the other climate services that we have developed are related to the water availability and water management. So the question is how much water will be available in the future. So we started to develop a co-design the service together with the potential end users, in particular the irrigation sector and also the hydropower sector. And in order the possibility to have in advance this information, so how much water will be available, it's an added value for most of the users. They can optimize the production of hydropower, and they can even save money in terms of energy trading. So we have developed a climate service called Safer Smart River, together with Romagna Acque, that is in charge to manage a big reservoir here in Emilia-Romagna, and Enel Green Power in Colombia that manage 2 hydropower plants. So basically, the concept of the climate services is quite similar to the previous one. So we integrate into a cloud computing climate data and artificial intelligence model, and we are able to provide information with forecast on monthly based. This climate service has been developed in the framework of Clara project with a collaboration with CMCC. Another climate service developed in the same project is EuroClimb, and it's quite similar to what has been developed by Arpaio and presented by Arpaio in the previous presentation. So we are able to, using decadal prediction, to provide in advance information related to soil water balance, and at the end is a useful information for the irrigation. So the user can modify the parameters of the crop and can have an updated forecast of the soil water balance, and so the amount of water that is requested for the irrigation in the next seasons, in the next decadal. We are now active in the ICISC project, our Horizon Europe research project, and we are working in Emilia-Romagna with Arpaio and other stakeholders like AREN and IRETI. We are working in a specific reservoir, in a specific basins, where there are multiple users of the same basins. And the idea is to provide them a climate service that is able to forecast with days and weeks in advance the availability of water for multiple concurrent users. Finally, we are now working in developing together with other partners involved in directed project. We are working in developing 4 climate services in 4 regions across Europe in order to support, in particular, the civil protection in disaster risk reduction and the municipality in climate change adaptation. So again, also in this project, we are exploiting seasonal forecast and long-term climate change projection for the design of the services. Thanks a lot for your attention.
Brilliant. Thank you very much, Stefano. That was really impressive and very interesting. Now, continuing on the same path, inviting innovative SMEs, the purveyors of climate services, they are already using climate forecast or ready to extend their activities to include them. I would like to invite Sara Del Gesso. She's also from a similar SME entity, which is called Amigo Solution. Sara, thank you very much for being with us, and over to you.
Thank you, Yaro. Thank you, everybody. I'm going to share a couple of slides to present Amigo. That is an SME based in Rome, Italy. And our mission is to co-design with users climate services for a resilient society. And we actually work on different sectors. We're active in the sector of reinsurance and insurance, agri-food, water and infrastructure, and energy. So that's an overview of what we do, all the type of information, climate information and services that we work on. And I would like to put it into the context of a timeline where we see now in the middle today. And then if we look at the past, then we can basically gather some general needs from all our different users. Of course, we can make some distinctions, but let's be a bit like general to have an overview. So in general, what do they need? They need climate data that are refined in resolution and that are bias corrected. And then they need also some data-driven information about extreme weather events. So what do we provide? So we provide bias corrected data and downscale climate data. In particular, we have a statistical downscaling method that is tailored to extreme events. There are specific, it's based on quantile mapping, and then there's a refinement for extreme events, adding like more skills on this specific part of the distributions. And we have some machine learning method to enhance the spatial resolution of climate data down to 300 meters, also for seasonal forecast. And we define ad hoc climate indices for a variety of situations. We can range from tropical cyclones to specific indices on agriculture productions. And it depends on the sector and on the needs, but we also provide this kind of services. Then we can look into the future and try to and wonder what our user needs. So what do they need? They need risk assessment over the upcoming decades to centuries, and risk assessment for the upcoming season. So in this context, we developed risk assessment based on climate scenarios, and recently within the H2020 project Focus Africa, also we're also working on decadal predictions. When we talk about risk assessment, we consider not only the hazards but also elements on the vulnerability and exposure. But we also developed a decision support system based on seasonal forecast. We have several examples developed within especially different European projects, but also accelerators and UN consultancy activities. So this is more or less an overview of all the things we're working on. And I would like to finish just with the faces of the people that made all this possible. And thank you all for the opportunity.
Thank you so much, Sarah. That was really brilliant and nice overview of your innovational skills and capabilities. And our last pitch presentation will be provided by Simila SME with a similar strong record of innovation, this time from Spain. It will be delivered by Eleftheria Exarchou. I really apologize if my pronunciation of your name was not correct. And she's from Mitiga Solution. Mitiga Solution is an SME based in Barcelona, if I'm not mistaken. Eleftheria, the floor is yours. Thank you very much for being with us.
Hi, thanks for inviting me. Can you hear me and can you see my...
Yes, we can.
Okay.
Yes.
Perfect. So yes, I'm Eleftheria Exarchou. I'm a climate scientist and a climate modeler. I work in Mitiga. Mitiga is a spin-off company, it's a startup spin-off company from Barcelona Supercomputing Center. And here I would like to give a very brief introduction of why we're very interested in being super users in Aspect and co-develop climate predictions with the partners in Aspect project. So to give a brief introduction about Mitiga, Mitiga is an insurtech company, so basically is bringing like innovation, technological innovation into the insurance and reinsurance sectors. And we are specialized in Mitiga in catastrophe modeling with a particular focus on wildfires, extreme weather, and volcanoes. And eventually we want to bring all of this together in a multi-hazard framework where we want to combine all of these perils into kind of a multi-hazard assessment. Risk assessment and hazard assessment, for example, in extreme weather, like in windstorms and hail, but also we would be interested in droughts, in floods, in hurricanes, and so on. So we are working in natural hazard and risk assessment, and we do that by doing physics-based modeling, by using state-of-the-art models. And we are planning to use the highest resolution that we can get our hands on. And whether this is possible to potentially expand this kind of resolution with machine learning tools or statistical downscaling tools. And since I mentioned machine learning is an important component in this kind of products and solutions, because, for example, they can bring solutions where there are data gaps, or machine learning methodologies can be used, for example, in downscaling. And we are considering machine learning methodologies where needed. And we also are interested in cascading effects in the sense that we are not looking at perils isolated from each other, but they are independent and interconnected. And this is something that we eventually want to take into account. So, for example, when there's a drought, and that would eventually increase the risk of a wildfire. And eventually, we want to improve knowledge for preparedness and adaptation, but in case also of wildfires for prevention. And my presentation will be brief. So basically, the temporal scales that we are interested in is right now is like the real time, where we are providing an analysis of a near real-time event by doing the footprint and intensity forecast using our in-house tools. But we also provide early warning, so a few hours in advance, alerts and notifications of an event that is being developed. And also short-term forecasts based on meteorological conditions and meteorological forecasts, which has the limitation that goes up to 7 days, which is more or less the meteorological window of data. So eventually we want to expand this. So we want to take climate variability and climate change into account. And this is where the Aspect project comes. And so we want to take into account seasonal timescales. For example, it would be very useful to know whether there's an ENSO coming out on the next season or not. And that will be particularly interesting for droughts and so on. And we also would like to, we're interested in multi-annual 2 climate timescales, which are exactly the timescales of Aspect. So between 1 and 5 years, between 5 and 30 years. So in the first case, we would capture some of the multi-annual variability. And in the second case, we will capture also the trends that come from climate change. So just, I'm not going to introduce the projects that we are interested, but this is just a brief overview of the partners that we are partnering in our different projects. So we have many partners, and we are involved in partners with a good source of funding. And we are involved in, so that means we are keeping the state of the art right now. And we are also very data driven. This is an overview of the data that we are using, which is available from service, like from C3A's, for example, database, or from Microsoft Planetary Computer database. So we're very data driven, and we are expanding this list according to the needs. And we want to expand this list basically with citizen longitudinal predictions. That's quite important right now. And finally, just this from the Aspect project. So I think that's how Mitiga could give some value. So for example, one really important thing is to use the forecasts, to align and apply for immediate needs for users. Also another very important thing for us is the extremes, because we are very interested in severe weather hazards and risk assessment. And we would be very interested in exactly the high resolution part that was introduced briefly from one of the panelists on the physical downscaling on certain use cases for extreme weather events. So that is exactly what we were looking forward to using from this Aspect project. And also we want to account for different sources of uncertainty. So basically, we would like to quantify source of uncertainty and communicate that to the end users, to the clients, that they are using our products for insurance, for adaptation and preparedness. And finally, all of this is to improve decision making and adaptation. And I think, that's it from my side. It was very brief, as I promised.
Very nice. Thank you very much, Eleftheria. That was really, really nice. And gave an overview about how this project might reach the users via partnering with SMEs like yours. And this is very important. So thank you very much, to all pitch presenter. So you can see the logic. So we have started with a project, but it's not just a project. The project is developing the new framework and toolbox to be applied across Europe by the local and regional applications, administrations. And those administrations are receiving also cascading funds in order to do that. So it was not just the project, but it was the lever that the project Climax is offering Aspect to reach out to the different regions. Then we had the regional administration itself and its environment agency providing the overview of how they might benefit from it. And then we had a presentation of 3 SMEs that are working with a number of users in different sectors. We have seen agriculture, water resource management, financial sector, energy, and so on. So this is the lever for the Aspect project to reach the different users and deliver the information and improvement that we are providing. So this is brilliant, excellent. Thank you very much. So all the presenters are either considering to apply as becoming super users or have already done so. And there are many others among you that are considering to do the same. So after the short coffee break that we will take until 12 o'clock, we will come back and we will break into breakout groups and discuss, answering your question about what does this mean, becoming super users, or you might pose the question about what is the way of interacting with you and so on. So I simply suggest that we break for 15 minutes, get back at 12 o'clock, and the last hour will be dedicated to in-depth discussion in small groups about how to become the super user and how you can help us to make our data and models more impactful. Thank you very much and see you at 12 o'clock. Thank you very much, Ella, for coming back for the last part of this user forum. I leave you a little bit time to get back. If you are here, you might also open your video camera in order to see that most of us are back. Thank you very much. So we have listened to many accounts of how climate information in general or how climate prediction might be useful for different public or private choices and how that information is delivered to policymakers or decision makers in different fields. We have listened to the accounts of the SMEs that are engaged in delivering the climate services for different clients. This is a very important lever for reaching to the users and exploring how the climate services might make the operational decisions more efficient or how the climate risk might be reduced. And then we have listened to different accounts of applications that are aiming at improving the quality of public or sectoral decision making directly from the users. In this last part, I promise we are not going to listen or see any slides, any presentations. It's really meant to create the space for your questions, your account, your stories, and your experience. So to do that, we have created 2 breakout groups. One is dedicated to the discussion about SMEs and delivering the climate services to different users. These breakout groups is called Climate Service Provision by Purveyors. And some of you have been allocated to this breakout group because of your background or randomly. The second breakout group is going to look into sectoral applications in different fields, including how the public administrations are using the climate forecast or climate information more in general. And again, to this group, we have allocated the people that come from this background or randomly the other participants to this meeting. Now, in a second, I will launch those breakout groups just to explain the way how we will be working. You might stay in the breakout group to which you have been assigned, or you might choose to join the other one. And this is done by clicking the button, move to another session. We have in every breakout group, we have a rapporteur appointed that will be in the first breakout group on service provision. It will be Sam from the Leeds University, who is also working on the Aspect project and especially on the helping to create the user forums and explore the user needs. The second breakout group, I will be the rapporteur on the sector application and public administrations. And I will be happy to guide and report back from the discussion. We will have roughly 40 minutes to discuss in those breakout groups. Again, you can take some time to pose your questions and you will get a qualified answer from the project teams. You might ask about what does it mean for you, how to apply for, until when you have the time to apply for becoming a super user. You might also ask more questions about how the information will be delivered, under which conditions and so on. But you might also use this space for sharing your experience. You might share your experience or insight from your working field on why the climate forecasts are currently used only to some extent, or what might improve the usage of this information. Finally, you might also elaborate a little bit on the specific request on the aspect user forum. So this user forum is really meant to be a safe place for exchanging ideas. And we are very happy to co-design our user forum together with you. So any feedback on how this forum has been designed or what we might improve next time is very welcome. So unless there are any questions that we need to take in this plenary, I would simply invite you to join the breakout groups, which have been open now. You should have seen the prompt asking you to join the breakout discussion. If you have not been assigned, please choose one of those two breakout groups and click on the button join the discussion. So please go to the breakout groups. I will stay a little bit longer here in the plenary to help you with your questions. And then I will join the breakout group too.